So I'm going to use the same data, but set it up as if it were a within subjects design. Okay, so this is when every participant is in every condition. This is the same exact data from last time. I think this is helpful to see like the differences between a within and a between subjects ANOVA, but don't really worry about that too much, right? We have our data here. All data is entered one row per participant. So participant one gave us 1, 2, 3 measures of a happiness. Participant two gave us 1, 2, 3 measures of a happiness, and so forth. So let's get our data into Jamovi. So now you see we have 4 variables. Double click. Participant. This is an ID variable. Click on B now. This is candy happiness. This is a continuous variable. It's the happiness scores. This is pizza happiness. Clearly you can call it different things. It's continuous. Our dependent variables in this program are 99% of the time going to be continuous. And finally, salad happiness is another continuous variable, and it's presented here. We know the 4 steps. First step, get our descriptive statistics. In this case, we actually have 3 different variables. We don't have to split our data set by anything. We just have to make sure we're getting our means and our standard deviations. There we go. Our means and our standard deviations are presented right here. They are the same means and standard deviations as we got before, and that makes sense. We're using the same numbers. All right, get your p-value. ANOVA. Repeated measures ANOVA. Okay? So my factor is food. My level 1 is going to be candy. My level 2 is going to be pizza. And you have to click in here for level 3, and you have to type salad, and you have to hit enter. Okay? So now it's saying drag my candy variable here. No problem. Drag my pizza variable here, and drag my salad variable here. What do we get? Right? Well, we get our repeated measures ANOVA output. We can see that it's a little different. What the within subjects ANOVA does, it's labeling this for residual, but you could call this individual differences, and it's telling us it's removing the percentage of variability that's due to individual differences from the calculation of our F statistic. So that's what's special. We have if we look at the data, right? We have 3 different participants, right? Like some participants are just going to be happier than others. This repeated measure analysis of variance removes the subject effects. Between subject effects, you could call these individual differences. This is a quantification of individual differences. Okay? We do not have our partial eta squared yet. We now do. And that's really great. We are going to want to go ahead and do the same thing to get our graph, estimated marginal means. Click food in here. Wait. And we want to make sure we're changing this to standard error. And you notice it looks very similar to the previous graph. It's nearly the same. And we now have our descriptive statistics, our ANOVA results, and we have our estimated marginal means. Okay? So I'm going to go ahead, click all, right click, that's what I did, right click, click all, click copy, and I'm going to paste my data in there for homework's sake, okay? But I'm going to look over here to interpret this. What do we know? We know it's basically the same result. We do have the p-value is a little bit larger. So if the null hypothesis were true, we would obtain data similar to our data 2% of the time, right? Well, this are we going to bet against the null? Yes. Are we going to say the null is false? Yes. Is there a 2% chance that we're wrong? Yes. If you take my way of viewing it, yes. And this is a large effect. Okay, so it's basically the same result we found before. So our interpretation, interpret your results, your p-value, and your effect size. I no longer need Jamovi up. I have everything I need from Jamovi. So how do we interpret these results? Number one, we had a significant effect. What do we know from that? Well, that's our p-value was less than 0.05. It was 0.02, and the population means are different. We just don't know where. It's also a large effect. It's a large effect size. So this is not just the means are different. The means are vastly different from each other. When we write our statistical sentence, I just copied the previous sentence. A one way within subjects ANOVA revealed that food consumption, all my means and standard deviations, caused a large and significant impact on happiness ratings. F, 2 and 4 degrees of freedom, 12.17, p-value is 0.02, partial eta squared is 0.86. All that is from the output. Degrees of freedom in my independent variable, degrees of freedom error.